Okay, question 3 says two boxes of mass M and 15 kg are connected by a light inextensible string passing over a frictionless pulley. A force of 500 Newton is applied at an angle of 40 degrees to the horizontal on the box of mass M as shown in the diagram below. The box of mass M experiences a frictional force of 150 newtons and a normal force Fn of 623.3 newtons. Now 3.1 is saying state Newton's second law of motion. So we say that Newton's second law states that, nice. And that's how you define your Newton's second law. Now 3.2 is saying calculate the value of M in the diagram below. So to calculate the value of M, looking at this diagram here, you can start by drawing the free body diagram first of a block M. So we have our normal force, we have our Fg, we have the force applied, and then we have the tension force, and as well as the kinetic frictional force. Right. Now to calculate the value of M in the diagram here is by looking at the vertical forces. Remember, if we have our force applied at an angle here, that means we can resolve this to Fx, and then also that one to Fy, right? Now, if we have Fx and Fy, we do understand this is coming from this being pulled at an angle. So it's in the first quadrant, meaning when we resolve our components, we have Fx in that direction and Fy in that direction. But then what we always know is that if we have to consider our Fnet, Ma for the vertical forces, so let me indicate for the vertical forces here, or components. Now, this would have to be what? Your normal force plus your Fy would have to be equals to your Fg, because now we always say that your vertical forces balance each other out. Now, this leads us to our Fn being equals to Fg minus Fy, which we always spoke about this to say that if your angle is being applied, if your force is being applied at an angle and this is being pulled at an angle, if you have a pulling at an angle, then I always made you note that your Fn is equals to Fg minus Fy. Then this becomes Mg minus F sine theta. But if you can check, we are already given Fn, the normal force. So that's 623.3, right? Now we have 623.3, and then we don't have our mass. But we know the gravitational acceleration is always 9.8. The force applied is 500. Then sine, we have the force being applied at an angle of 40 degrees. Now that means we can calculate here. We will have the 623.3 and then here the 9.8 M. Calculating that, negative 500 sine 40. That's a negative 321.39. Then we're going to take it and transpose it over to this side. So if we say 623.3 plus a 321.39, then we get 944.69 is equals to 9.8 M. Now if we divide both sides by 9.8, then our M should be equals to 96.396, which will be 440 kg. Right, so rounded off to 2 decimal places, that's 96.40 kg. Okay, so we have 3.3. It says calculate the magnitude of the acceleration of the system as it moves towards the direction indicated on the diagram. So it's moving to the right. So that means this 15 kg block will be moving upward. Now we did speak about this to say that if it's moving upward like that, then tension needs to be longer than Fg here, right? So that's how we'll be drawing the 15 kg. Now, if we are to apply our Newton's second law separately, this is now how we'll have that. Okay, so I'll be applying my Newton's second law separately. Then for this block here, I will have F net is equals to MA. So now I'm considering the horizontal forces. There will be Fx. So note positive direction, negative direction, positive direction, negative direction. Then this is Fx minus tension minus Fk, because we do understand this system is moving to the right. Then MA. Fx breaks down to what? F cos theta. Then let me arrange Fk minus T like that, because I know T will be the unknown. And then what's my force applied is 500 cos 40 degrees. They said the Fk is 115. So it's given there, minus T. And then here we will have, remember the mass we have now calculated, it's 96.40, and then A. Now it's only a matter of just punching this into your calculator. You have your 500 cos 40 minus 115. So this will give us 268.02 minus T, and then that's 96.40 A, right? Then to make T the subject of the formula, 268.02 minus 96.40 A is equals to T. Then I will call this equation number 1. Now, to do my F net for this one here, that's T minus Fg is equals to mass times acceleration. So obviously here I only have vertical forces to consider, no horizontal forces. Then T minus 15 times 9.8, and then 15A. So it's an unknown. Then you punch that, the 15 times 9.8 will give you 147, which will be the minus 147 here, and then 15A. Again, make T the subject of the formula. That's 15A plus 147. Then call that equation number 2. Okay, from here, can say now let's equate equation 1 and equation 2, right? So I can have 15A plus 147 and then 268.02 minus 96.40 A. Then all the numbers with the variable A on the left-hand side, and then all the constants on the right-hand side. Then that means it's 15 plus 96.4. That's 111.40. Then 268.02 minus 147. It's 121.02. Then 111.40. And then here 111.40. And then my acceleration, that's 1.09 meters per second square.